everyone.
Welcome to day 4 of Science Week. Today we are looking at...
Let's make some noise.
Yeah! Just waiting for 1 or 2 people to carry on joining us here. So in the meantime, we'll say hi to everybody who's been with us on days 1, 2 and 3. It's awesome to have you with us again today.
Please don't forget, ladies and gentlemen, that with this there is a worksheet that you can accompany with your link. So on your email address or the email that you received, just above the Zoom link, there's the worksheets. And the worksheets actually have got some fun start activity, a step-by-step method guide of how to do the practical with the students at home or at school. And we also have some differentiated questions when it comes to the working scientific skills. So whether or not you want to plan an investigation, capture and analyze some data, or evaluate what you've done. Okay,
so we said that today we are looking at how we make noise, and we have our very own personal way of making noise, and we're going to see what that feels like and use our powers of observation today with that, okay? So what I'd like you to do is just to take your hands and make your fingers nice and flat and just pop it against your throat here, and we are all together going to make the deepest, lowest noise you can. Are you ready? Okay, so now we're going to make a medium pitch noise, okay? So I don't want you to go as squeaky as you possibly can, just a little bit higher. Are you ready? And then the last one, we're going to go as high as you possibly can. So I want the squeakiest noise you can possibly make. Are you ready?
All right, ladies and gentlemen, boys and girls, as you know, we are going to look at sound. Now, our 2 learning objectives for this topic today is that we are able to identify how sounds are made, and that these sounds that we are actually made through the process of vibrations. We also need to identify that these vibrations of sound can travel through different mediums, like, for instance, a gas, like air, liquid like water, or solid like a wooden bench or piece of metal. And then those vibrations, as they travel, that's how they reach our ear. Now, one of the best things that we can look at is not only the noise that we can make with our voice. So we know that our singing voice is one of the beautiful ways in which we can make sound. La. But there are different instruments that we can also use. Now, the most modern ones that you can think about, the ones that you might know, is your set of drums, or your lovely guitar, ding, ding. You've got violins, you've got flutes, you've got cellos, you've got so many different instruments out there. But if I look at my little box of musical instruments, before we've got all those little modernized ones, you can see that every single one of them will use the same principle to make a noise. So if I've got this one here, what do you notice I have to do to make a noise? Let's look at my little drum that I've got here. I've got my little shaker. And I've got my little, no, that's my maraca. And of course, last but not least, my little musical instrument here where I've got it. Every single one of them that I've used, I had to do something to them. I had to hit them. I had to stroke. I had to bash them. Every single one of them actually had to be hit. So I have to put in a little bit of energy. That caused that object to vibrate. And those vibrations is what actually is creating the sound. And then as that sound is created, those vibration, it travels through the particles we have in the air. Now, these particles, these gas particles, are all over the place. So that sound wave actually hits that air particle, that hits another one, that hits another one, and hits another one. And that is how sound is transferred.
And we can show that using our Jelly Baby Wave machine. So this is a jelly baby wave machine that we created earlier, okay? So as Chris said, in the air around us, there are particles and we can't see them, and that makes it really, really difficult to understand what's happening in terms of sound, which is traveling. So what we've done here is we have popped a jelly baby on each one of the ends of one of these kebab sticks to demonstrate one of the particles in the air. And they are spread out throughout the room, aren't they? In the same way that they're kind of spread out here. Now, we've obviously just shown them in one direction, but these would be going in all directions all over across the room. So when we earlier on saw Chris, who was making musical instrument noise, so he was either banging a drum or he was scraping one of the pieces or he was shaking something, he was actually creating a movement in the wave at his end. So Chris, if you want to be your drum demonstrator.
Yeah, gosh. So imagine if I hit it again. Sorry, let's try again. There we go.
Look at that. Okay, so don't forget that when you make a noise, other people can hear it, but you can hear it too, can't you? And this is shown quite nicely here in our jelly baby wave machine, because the sound will travel. So as one jelly baby is hit, the sound then transfers to the next, and to the next, and to the next, and to the next, and that's the same in the air. So as Chris hit the drum, that created the air particles to move closest to him, which passed on to the next particle and the next and the next and the next. And eventually you guys were able to hear it at home or at school.
Now there's a second way in which we can demonstrate how sound travels. And this is where we can use a slinky. So it's the same principle where particles actually hit each other and they travel through. So if we hold it there, and boys and girls, ladies and gentlemen, if I show you here, if I were to squeeze it, you can actually see the wave traveling back and forth. Or that way. And this is basically the same principle how sound travels. It hits one particle that hits another, and that is how sound is transferred through these vibrations. Now, sound needs a medium to travel through. But there's something else that we also need to know about sound. So one of the most easiest objects that I love to use is my little whirling pipe. Now, guys, to see what you hear, especially when I spin this object, what happens when I spin it slowly? What happens when I spin it fast? What do you hear? What's the difference in sound? So I'm just going to do a little bit of a medium spin here and see what happens. Now, what happens to sound if I were to spin it a bit slower?
Well, that's definitely a lower pitch, isn't it?
What happens if I spin it faster? Yes, you might have noticed that if you increase the speed at which these vibrations travel, there's a change in the pitch. That slow is low and fast is high. Yes, so slower is a lower pitch, faster is a higher pitch. But remember I said to you that sound uses a medium to travel through? What would happen if I were to block the air from traveling through my pipe? And with this, I've got a little plastic bag. And if I put the plastic bag on the end of my whirling pipe and I hold it there very tightly, so no air can go through, what do you think will happen? Will I still hear a sound? Let's listen to this. Nothing. And that is because sound needs a medium to travel through. Now, you might have heard the following phrase, nobody can hear you scream in space. Well, that is absolutely true. Now, I know in space we've got planets and asteroids and everything like that, but space itself actually don't have like air particles that you see on planet Earth. So it's very difficult for sound to travel through there. Now, if we are going to go on to our next investigation. Now,
okay, so for the next bit then, what I want to show you here is I have got a tiny little hex nut. If I just show you that there, can you see that? Okay, Chris, do you want to hold yours up at the same time so you can see the difference in size there? So I've got a really small one, Chris has got a nice big one, and we're going to pop each of our hex nuts into a balloon here. and we're going to blow up our balloon. Should we have a little competition?
Oh, yeah, of course.
Blow our balloon up, yeah. Let's make this scientific, okay?
Yeah.
So we'll have a little investigation to see who can blow their balloon up the fastest. So we've got to think about our variables here, our independent, dependent, and control variables. So our independent variable, I'll use the pump, and you use your...
I'll use my lungs.
Your lungs, yeah. Okay, so that's the thing that we're going to change. So our dependent variable, the thing we're going to measure is who manages to blow their balloon up the fastest.
Yes.
Yeah. And then our control, whoa. No cheating. Because all our control variables have got to start at the same time.
That's true.
Otherwise, that's going to make a difference, isn't it? Okay. Are we ready? Safety first in case our balloons pop. Right. Wait, are we trying it as well? I don't think we discussed this. Look how calm you are. Oh.
All right, now, boys and girls, ladies and gentlemen, we've got two different size hexagonal nuts. What we are going to do is we're going to spin them, and I want you guys to hear what is the difference in the sound that they make. Sarah, would you like to go first?
Okay, hang on.
Interesting.
Yeah, it's quite high pitched.
Now let's try mine. Oh.
That's definitely lower.
That's definitely lower. Try yours again. Yes, yours is slightly higher. Oh. Nope. Yes,
Does it make a difference how fast you do it?
Well, let's see what happens.
Okay, so let's start off doing it slow. Hang on. And then if I speed up.
Oh, so speed is key with that one, especially with the whirling pipe, but with this as well. So the size of the object actually have an influence of what the pitch of the sound can also be like. So that again brings us to the idea about, fast moving, slow moving objects, and speed is key. But we're not going to stop there. Boys and girls, ladies and gentlemen, it's now time for your
investigation, okay? This is not, however, the last bit, because Chris has got something really cool to show you. For all you Star Wars fans out there, after I've shown you your investigation, he's going to show you something pretty awesome, okay? So let's have a look at what it is that you guys are going to do today. Now, at the start of the session, Chris went through with you our different musical instruments from around the world, didn't he? And he said that in order to be able to make a sound, we have to be able to get the air particles to move. And you can do that in lots of different ways. So either by tapping something, or by shaking something, or by scraping something, sound can be made, okay? So you guys are going to have a go at making your own musical instruments. And you can go as crazy with this as you like, okay? There are a multitude of different types of musical instruments. So have a think about how you can get air particles to move in your own musical instrument. Now, one of the ideas that we're going to give you is to create your own little guitar. Now, all I've done here is I've taken a cardboard box, and this could be any shape or size, okay? So you could have a go with a cardboard box, like a shoe box or a tissue box or a cereal packet. Any of these things work. If you happen to have a bowl at home, you can do it with a bowl. Just be quite careful, because it's obviously quite rounded, and if you're putting the elastic bands over, they can have the tendency to ping off. So just make sure that you're doing the elastic band, stretching them with a parent or someone who can supervise that properly with you, okay? So in my, what I call this a guitar? I don't think I'm going to call it a guitar, because it's square, and I play it on the table with my rubber bands that are across the centre of my hole here. Now, in terms of my independent variable, I could be changing things like the size of the hole, the shape of the hole, whereabouts the hole is on my box. It could be on the front, on the back, on the top, on the bottom. It's completely up to you, okay? And what I want you to do is have a look at how you can make sound from your musical instrument. So I've put some different length rubber bands on across my box here, look, and if I then pull on one of the rubber bands and let it go, it gives off a different sound. Okay, so what I could do is to change the pitch. So you know how we talked about different waves creating different sounds, whether they are high, medium, or low. So I could, for example, if I'm looking at my really, really thin rubber band, if I pull that, so if I just start off by pinging that so you hear what it sounds like normally. And then if I start to pull that at the side, can you hear what happens to the actual sound there? It gets higher, doesn't it? Okay. So have a go at creating your own musical instrument. You can use rubber bands, you can use pieces of fabric, cling film, boxes, bowls, whatever you happen to have, balloons, etc. But there is actually guidance on our worksheets. Now, don't forget that you can either plan your investigation, so decide what your dependent, independent, and control variables are going to be. You could have a go at looking at analysing the data, so collecting the data. How are you going to decide what data you're collecting? Or you can evaluate your investigation, have a look at what you've actually created and think, well, if I was to make this again, how could I make my musical instrument even better? Okay, so I did tell you at this, just before we started looking at your own investigation, that Chris was going to show you something really cool. Are you ready, Chris?
I am. All right, boys and girls, now, as Sarah has mentioned before, there is a way in which you can make a different musical instrument. But this one is related to any of those any of you who are a Star Wars fan. Now, I am a massive Star Wars fan, and this is one of the favorite things I've done. So I've got 2 bottles. You can use a Coke bottle or any soft drink bottle. I've just got 2 plastic bottles that I've got, and I've cut off the ends of my bottle. I've also then used the very sharp implements. You might want to ask your parent, guardian, teacher to help you out. And I've just made a small hole on each of the sides of the top of my bottle, so on the lip. And the last thing that you'll need for this one would be a metal slinky.
We also did say, didn't we, that this would work particularly well with a crisp tube.
Yes, so like a Pringles can or Pringles shaped can. That's one of the ones that we can actually use as well. So, ladies and gentlemen, boys and girls, so what we do is, as Sarah demonstrates, she's going to put the slinky through the holes I've made at the top.
I'll pick through, hang on, there it goes, can we see?
And she's going to roll it all the way through. Yeah,
make sure
so it's nice and tight. Yeah.
I might go
fantastic.
A couple of times there.
No, just once or twice.
Just once?
Yeah.
Yeah, okay.
All right. Now hold it to the side, so the speaker's at the bottom.
Okay, hold
it. And now listen very carefully. What noise could you hear that you might have heard in some of the Star Wars movies? Oh yeah, you're by all means.
Hang on, let me shoot you back. Wait.
Now, boys and girls, ladies and gentlemen, what I'm using here is I'm actually using a solid to transfer the sound through. So the sound vibrations actually using a solid to do that. And this is the same technique, funny enough, that they used on the old Star Wars movies to make the laser gun noises. So when they were shooting, you know, especially Luke Skywalker, Princess Leia, Han Solo, and Darth Vader. Now, boys and girls, ladies and gentlemen, everything that we've done here covered the whole idea about sound, how sound is made through vibrations, how these vibrations travel through a medium, especially air and a solid, and how that reaches our ears so we can hear all of that. Boys and girls, ladies and gentlemen, thank you so much for joining us today. We do hope that you had an enjoyable time and that you had some real fun, or you're going to have some real fun.
I can see that someone's already made their own musical instrument down there, which is fabulous.
Absolutely.
Send us your pictures.
Please do send your pictures for our social media accounts so that we can actually demonstrate and show to the whole world what you guys have accomplished. Thank you so much, from the bottom of our hearts. We hope you guys enjoyed it.
Bye.